3 steps to follow for cantilever beam. First step is to find out the CG. So the formula will be x bar is equal to summation AX divided by summation of A. So area of each column we have to find out, or you have to consider. You will get the x bar. Okay, next we have to consider the upper story, or we can say top story for the analysis. Suppose this is the frame given. There are two frames. One is bottom story, second one is the upper story. Okay, now we have to take the section for the upper story analysis at mid height of each column like this. So the section will be like this, and this distance will be h by 2. Okay, then we have to use the first two assumptions, and the first two assumptions are point of inflections are located at mid span of beam and mid height of the column. Before that, we have to use the relation, that is our third assumption, that the axial force P1 is proportional to the centroidal distance x, which is equal to axial force in column second, that is P2. It is proportional to with centroidal distances is equal to axial force in column third is proportional to the centroidal distance z. So one relation you will get using third assumption. Okay, then after that third assumption, what you have to do, you will get one relation. After that, we have to take the summation of moment at mid height of the right end column. Suppose this is the right column and this is the mid height point. Suppose that point is x. So we have to make the summation of moment at point x equal to 0. समजते का बघा? So there are two conditions basically we have to use. First condition, third assumption. Axial forces are directly proportional to the centroidal distance. From that, you will get the ratio of the axial forces. Okay. Then second condition that we have to use, that is summation of moment at mid height of right end column. Summation of moment at mid height of right end column means summation of moment at point x is equal to 0. So we are having two equations, and you can get the two unknowns from this, so that you will get the axial force. If you use these two conditions, what we get, we will get the axial force. And what are the axial force? These are the vertical force in a column. So these are the axial force. Okay, now in case of portal method, we are using the summation fx equal to 0 condition to get the h. So this h we have got using the summation fx equal to 0 in the portal method. So horizontal shear is twice for interior column as that of the exterior. But here we have to use the third assumption, and we have to make the summation of moment at mid height for the right end column to find out the vertical forces, or we can say axial forces. Means what? At a joint, we are getting the axial force first, or the vertical force first. Whereas in case of portal method, we are getting the horizontal shear, or we can say horizontal reaction. That is the basic change between portal method and cantilever method. In portal method, we are getting the horizontal shear. In cantilever method, we are getting the axial force. Axial force are nothing but we can say vertical forces. Okay. Similarly, once you perform the analysis for the upper story, consider bottom story, and same funda we have to apply for the bottom story. Now, in case of portal method, if I draw the FBD of one joint in case of portal method, suppose this is the portal method, and this is the value of h. That h we have calculated using summation fx equal to 0. Now for this joint A, tell me how many unknown forces are there, maximum unknown forces in portal method. Maximum unknown forces in case of portal method. Maximum unknown forces in case of portal methods are, कोण सांगेल? Maximum unknown forces in case of portal method, and these are the inflection point. Yes, किती असतील portal method मध्ये maximum unknown forces? Maximum unknown forces काल सांगितलं होतं किती असतात 1 2 3 4
3.
3. Very good. So there are three forces. Out of three forces, how many are vertical and how many are horizontal? Yes.
One
Two
horizontal,
horizontal,
one
one
vertical.
vertical.
One horizontal and two vertical. Okay, two vertical forces are unknown and one horizontal force was unknown. Means here this will be vertical, this will be horizontal. Suppose this will be, I will say h1, and suppose this will be v1, and at this point suppose this will be v2, and this h value you will get suppose 3 4 kilonewton using summation fx equal to 0, summation fx equal to 0. Okay, suppose this is 3 kilonewton, this is 3 kilonewton. Means in total method at any joint the maximum number of unknowns are 3, maximum numbers unknowns are 3. Out of 3, 2 are vertical and 1 is horizontal. So to solve for that maximum 3 unknowns we are having 3 conditions. And what are that 3 conditions? What is the sequence of that 3 conditions? If these are unknown forces, 2 vertical forces and 1 is horizontal force, so what is the sequence of that 3 equation fx fy moment? Initially which condition we have to use, what is the second condition, and what is the third condition? What is the sequence of condition we have to use? कोण सांगेल? Sequence is very important. Yes, हे पण सांगितलेलं आहे काल. फर्स्ट कंडिशन कोणती यूज करणार तुम्ही? यस धनराज.
fx.
Very good. So initially we have to use summation fx equal to 0. Correct. Second condition.
Moment.
Very good. Summation of moment either at x point or either at that y point equal to 0. And definitely the last condition will be summation fy equal to 0. In total method, 3 unknowns, 2 are vertical, 1 is horizontal, and the conditions are fx moment and fy equal to 0. Now in cantilever method, if this is the fbd of the cantilever method, what is the change? So in case of cantilever method, in case of cantilever method, now here one force is vertical which is unknown and two horizontal forces we have to find out. Okay, here definitely three forces are unknown here also. In the cantilever method also three forces are unknown. So we have to use three conditions. If out of three forces which are unknown, one is vertical and two are horizontal. Okay, this is the general FBD of cantilever method, what you will get during the analysis. Maximum 3 unknown forces are still out of 3. 2 should be now horizontal and 1 is vertical. We are having 3 conditions. Now tell me what is the sequence of condition we have to use. Which condition we have to use first, then second condition and third condition. What is the sequence of condition we have to go with? Yes, first condition will be now first condition काय असेल बघा
Summation of
विद्यार्थी.
Fy.
Very good, summation of fy, because here only one vertical force is unknown, so initially go with summation of vertical forces equal to 0. Very good. Second condition.
Moment.
Correct. Good. Second will be movement, either x point or either that y point, and last will be summation fx equal to 0. Good. So in cantilever method, fy movement fx. In total method, fx movement fy. This is the change. This is the change. Okay. This sequence you have to consider. So in cantilever method, use summation fy equal to 0 first. Secondly, summation of movement either at this point or either at this point equal to 0. Then last summation fx equal to 0. Now here, so this 2.7 kilonewton force is shear force or the axial force. Yes. shear force or axial force? 2.7. कोण सांगेल? 2.7 kilonewton force is the shear force or the axial force? First, काय असेल हा force?
Axial.
Axial force, vertical force for a column, it is axial force. Good. Okay, so this is the main concept or the change in the cantilever method that we have to understand. हे समजलं, cantilever method समजली. ठीक है. Now we will see the numerical directly. So this is the numerical. Using cantilever method of approximate analysis, find axial force in each column. Assume area same for all the columns, means the cross-sectional area we will consider A for all the columns. Area is what? A. It will be same. It will be same means we will assume that area it is same. So you can say 1 I or twice of I. We will consider A. It is common for all the columns. It will be constant or we can say same. Okay. Now step number 1 is to find out the centroidal distance or we can say X bar. So what is X bar? We have to find out here. Now here, so this is first column, this is second, okay, considering the total frame. This is third one. Area I will consider here A, here A, here A. So centroidal distance, this is I think 6 meter, this is 8 meter. Direct आता L by 2 करायचं नाही. So what we are having, so X bar is equal to, here there are 3 different columns. So A1, X1, okay, A1, X1 plus A2, X2 plus A3 X3 divided by total area. Now tell me what is the total area here? Total area का असेल? A plus A plus A. Total area will be what? 3 into A. Now here first will be what? A1 X1. What is A1 A? Okay, A1 A2 A3 which is equal to A, which is equal to A. Now what is X1? Distance from the left side column. So that X bar we are calculating from the left side column. So ultimately as we are calculating the centroidal distance from the left side column, so X1 will be 0. So A into 0 plus what is A2? That is also A. That is also A. So what is the distance? What is the distance of that A from the left side column? X2 का असेल? X2 काय असेल सांगा? Distance of second column from the left column. What is the distance? What is the distance? Distance of second column from the left side column. That will be how much? That will be 6. Very good. And what is X3 then? This is A3 and X3. This will be X3. Again A3 will be A. And what is X3? Distance of third column from the left column. This will be 8. This will be 6. That will be what? 14. इथं काय घेतलं? Area 1 घेतलेला आहे. You can consider A. So what we get here? This will be 0. This will be 6A. If I consider instead of 1, it is A. And here it will be what? 14A. So 14A plus 6A, 20A, isn't it? 20A divided by total area is what? A plus A plus A, 3A. A will be cancelled out. And 20 by 3, it will be 6.67 meter. So this is the X bar distance you have got. And that distance, it is from the left side column. समजतं का बघा? हे डिस्टन्स कुठून घेतलं आपण? फ्रॉम लेफ्ट साइड कॉलम. सो दॅट्स वाय दिस इज द सेंट्रॉइडल डिस्टन्स. And that 6.67, it is from the left column. So the distance of column 1 from the centroidal axis, it is 6.67. Now tell me what is the distance of second column from the CG axis? सेकंड कॉलमचा डिस्टन्स काय असेल मग CG axis पासनं? Yes.
0.67.
Very good. 0.67. This total is 6.67, हे आहे 6, मग राहिलं किती 6.67 minus 6.67. Okay, and what is the distance of this third column from the centroidal distance or centroidal vertical axis? This total is 8. Now this will be 0.67, मग राहिलं किती this distance किती असेल? Yes, this distance axis to the right side column, this distance we want, this distance, this we know now, this is 0.67, 0.67. Total is 8. Okay, this total is 8. 8 minus 0.67, so this will be what? 7.33 meter. Okay, so initially find out the centroidal distance, or we can say CG, then draw the FBD of upper story. So this is for the bottom story, that we will consider afterwards, next calculation. So currently concentrate on the upper story. So take the section for the upper story at mid height of each column. So this distance, it is what? H by 2. It is at distance H by 2. And we know that these are the axial forces. These are the axial forces. So these direction we have assumed. These direction we have assumed. This is the direction of the axial force. Now this direction you can consider upward. This may you can consider upward, or this may you can consider downward. So what is the logic here? So this is the centroidal axis. Okay. So the axial forces on either side, if they are tensile away from the joint, if they are tensile, then on other side that will be compressive. Total tensile forces should be equal to total compressive forces. That is the logic. So that's why if I consider these two forces downward, means away from the joint, that will be tensile. VGF and VHE, they are away from the joint, or we can say these are tensile one. Okay, त्यामुळे हे दोन कसे दिसतात तुम्हाला? Downward. And the force on the other side of the centroidal axis, it is in opposite direction. It is in the opposite direction. Logic समजते का बघा? So these two forces are tensile. These are tensile, isn't it? On left hand side of the axis. So that's why on the other side, on the right side, the forces are there that should be in the opposite direction of the forces that we have assumed on the left side. मग लेफ्ट साइडला आपण काय केलं? टेन्साइल अज्यूम केलं, or we can say downward. So on the right side it should be upward. समजते का बघा लॉजिक? Or else you can consider these two forces upward. These two forces you can consider upward. Now tell me, in that case, what is the direction of this third axial force? सांगा. थर्ड ॲक्सियल फोर्सची डायरेक्शन काय असेल? हे दोन जर अपवर्ड घेतले मी, इफ आय कन्सिडर डाउनवर्ड, दिस विल बी डाउनवर्ड. लॉजिक समजते का बघा? आता इथं तीन फोर्सेस आहेत, चार असतील तर हा जो चौथा असेल तो पण कसा असेल? डाउनवर्ड असेल. कारण ॲक्सिसच्या एका साईडला जर अपवर्ड घेतलं तर अदर साईडला सगळे फोर्सेस अपोजिट डायरेक्शन मध्ये घ्यायचं आहे. Tensile forces should be balanced with the compressive set of forces. That is the only logic. And this is our assumption. This is our initial assumption. These two forces are tensile, or you can say downward. Okay, downward, and this is upward. हे पण opposite पण करू शकता तुम्ही. दोन्ही forces घ्या upward. हे दोन्ही upward घ्या तुम्ही, आणि हे downward घ्या. After the calculation, if answer is minus, modify the direction. आता सांगा मला, this is the assumption. After the calculation, suppose VGF हा जर आला मायनस, तर काय मॉडिफाय करणार सांगा डायरेक्शन. After the calculation using this direction, if the answer for VGF, axial force in this column GF, if it is minus, then what will be the modification in the direction? Sanga. VGF जर मायनस आलं तर काय करणार डायरेक्शन, मग कशा मॉडिफाय करणार? यस, कोण सांगेल? So this is our assumption, downward and this is upward after the calculation. Suppose VGF is minus, so how to modify the direction? VGF जर मायनस आला म्हणजे काय झाला, तो डाउनवर्ड असेल की अपवर्ड असेल? मग फर्स्ट upward. Very good. Minus अगोदर initially we have assumed downward, after the calculation answer is minus, so we have to modify the direction upward. हे जर upward केलं, so what will be the direction of VHE? What is the direction of this force then?
Upward.
Very good. This will be also upward, because on any one side direction will be in the same direction. This will be upward, this will be upward. हे दोन्ही जर upward असतील तर राईट हँड साइडचा जो फोर्स राहिलेला आहे त्याची डायरेक्शन काय असेल? This force will be downward. Very good. This is the logic. एवढा अवघड येणार नाही. This is the logic. Okay. Now here find out the centroid. Then from the third assumption, axial force in columns are with proportional to their distances from the centroidal axis. So this VGF, it is proportional to the 6.67. VH, it is proportional to the distance 0.67, which is equal to VKD, it is proportional to the distance 7.33. So this is one equation you have got, or one relation you have got. Now this is the proportion, you are getting the relation, one force in terms of other. So what we want one additional condition. And what is that condition? Suppose this point is x, so make the summation of moment at that point x is equal to 0. What is the second condition we have to use? Make the summation of moment at mid height of right end column. Mid height of right end column. So if I do so, if I make the summation of moment for the right end column, okay, at a point of counterflexure or at mid height. So this is one condition I have got. This is the condition, or this is the equation I will get if I use that moment equation on the right end column. Okay, this is the right end column at mid height. So this is 20, this is 2 meter, so clockwise is minus, so 20 into 2, that will be 40. And for these two axial forces, movement will be anti-clockwise, that's why plus. So this will be VGF, so 6 plus 8, that will be 14. And for HE, this will be 8 anti-clockwise, that's why positive. So this is one relation you have got, and the proportional relation already we are having. So comparing, if you compare this condition with this equation number 2, you will get the all the forces, you will get the all the axial forces in a particular column. समजते का बघा? Initially use the proportion, that is third assumption. Next, taking the moment about point of inflection of right end column. Okay, right end column ला moment घ्यायची आहे. So if you take the moment, you will get second condition. So use that two conditions to get the axial forces. Answers are positive. After the calculation, answers are positive, means our assumption is correct. First two are away, downward means away from the joint, tensile, and third will be upward, that will be compressive. हे कन्फ्युजिंग होत असेल तर टेन्साइल कॉम्प्रेसिव्ह नाही लिहिलं तरी चालेल. Answer is positive means our assumption is correct. So that force is downward. FBD करताना downwardच दाखवायचा आहे. That's it. So we have got the axial forces. Now next, what is the next condition? We have to use each joint separately, or we have to draw FBD of each joint separately, and we have to apply the condition. Suppose this is, I will consider joint A. Now this force you have calculated using our third assumption. This is the axial force. Answer was positive means our assumed direction, which is vertically downward, it is correct. Downward 2.7. And what else we have to find out? So here we have to find out first vertical force, okay, first horizontal force, second horizontal force. So these are the forces we have to find out. These are the forces first, second, third. Now here three forces we have to find out of three. Two are horizontal, one is vertical. So to solve this, conditions are summation Fy, isn't it? Summation of movement at this point x or at point y. So you can take the summation of movement at x or y equal to 0. And lastly, summation fx equal to 0. Logic will going to remain the same. Logic same as असेल. Okay, काय logic असेल? So these two forces will be in the opposite direction for the next joint. Now see here it is upward, for the next joint it will be downward. This is on the left hand side, for the next joint B it will be on the right hand side. Logic will be same. What is the change here? So in case of portal method we have calculated horizontal shear, but here we have got the axial force. Once you get the axial force, use the conditions, that is summation Fy equal to 0, moment equal to 0, and summation Fx equal to 0 to get the all the remaining forces using these three conditions. Okay, this is for the upper story. Next for the bottom story. Now for bottom story, we have to consider upper story as it is. Upper story as it is, and the ratio will going to remain the same. काय चेंज होणार? सेंट्रॉइडल डिस्टन्स सेमच असणार तुमचं 6.67, ते काही चेंज होणार नाही, ते पूर्ण फ्रेमसाठी कॉन्स्टंट असेल. इट मे बी युअर बॉटम स्टोरी or it may be your upper story. So what else will change? So here VFA, first column divided by 6.67 is equal to second axial force VEB divided by 0.67 is equal to VDC divided by 7.33. So just name of that column will change for the axial force. Distances are going to remain the same. And the second condition, take the summation of movement right end column at a point of inflection. At this particular point, we have to take the summation of movement. Now, I think this is 4 and this is 3. Okay. Height of column will be how much? 4 and 6. Okay, 4 and 6. 4 and 6 means this will be h by 2, this will be 3. Okay, so this will be 20 into 7. 4 plus 3, 7. That will be 140. And the moment of that, 40 into 3, that will be 120. So what we get here, 260, it is the bending moment due to that horizontal load. Then bending moment due to that axial forces. It will be what? VFA into 14 plus VEB into 8. So this is the second relation we have got. So use that both the relations, proportion and the moment at right end column equal to 0. You will get again axial force. Ratio will be the same, but the value will be the different. Value will be definitely different, as the moment equation will be different. We have considered upper story load also for the bottom story. So these are the axial forces now. Now what is next here? Consider this first joint, second joint and third joint. Take the section at mid span, mid height of each column and beam respectively. Draw the FBD. Draw the FBD and use the condition summation Fy, summation of movement and summation Fx equal to 0. Now see here. So these are the two forces already you have calculated for joint 1. Same forces will be there for the second joint, but in opposite direction. Now that 2.7, it is downward. So for joint 2 it will be upward. 4.05, it is on the left hand side. For joint 2 it will be on the right hand side. And this is the axial force we have calculated using the third assumption. What else is remaining? This is first force. Okay, how many forces are unknown? This is first, this is second, this is third. So again we are having 3 unknowns. So at a joint the maximum unknowns will be 3 in cantilever method. Out of 3, 2 are horizontal, 2 are horizontal, 1 is vertical. 2 are horizontal here, 2 are horizontal, 1 is vertical. So use summation Fy, summation of moment, summation Fx equal to 0. Same way for internal joint also. There will be 8 unknown forces Out of 8, 5 are known to us. These two, again this one is known to us, and these three forces, we have to find out using that conditions. So once you get all the forces, which are axial force and the shear force, last is drawing the superimposed BMD. So for BMD, first point, for beam, in case of beam, shear force into L by 2. In case of column, shear force into H by 2. This is the formula we have to use. Now, so this here, the bending moment is what? 8.10. Why it is so, that we will discuss. So we have to see the first joint. So this is the first joint. Okay, this is the first joint. Now tell me, what is the shear force here? And the bending moment you have written, that is 8.1. What is the shear force here? Yes. शेअर फोर्स किती आहे ह्या डायग्राम मध्ये इन केस ऑफ बीम? Yes, I think this distance is 3 meter. Total span is 6 meter. So L by 2 is 3. So या डायग्राम मध्ये शेअर फोर्स काय आहे? कोण सांगेल?
2.7.
2.7.
Correct. Good. 2.7. And what is the bending moment? Bending moment formula is shear force into L by 2. So this L by 2 distance is, I think that total A to B is 6 meters. So L by 2 is 3. So 3 into 2.7. 3 into 2.77 is what? 8.1. 8.1. So that's why in case of BMD, this is 8.1. So both the moments are in the same direction. So that's why BMD will crosses the reference line. So here it will be downward. So at next point it will be upward. Bending moment at midspan will be definitely 0, because these are the point of inflection, or we can say point of contraflexure joined with the straight line. Similarly, in case of column, now in case of column, again we will consider one of the joint. Suppose this is the column. For this particular column, okay, what is the shear force for this particular column? First,
9.99.
very good, 9.99 into H by 2, you will get the bending moment. Okay, so this is the cantilever method, and this is the last point of unit number 5. I will share you the notes. So in the next week, so hardly I will call 2 or 3 sessions to complete our unit number 6, because unit number 6, it is mostly theoretical part. I will give you the notes, PDF notes for unit number 6 as well. Okay, so we required 2 or 3 sessions to complete our total syllabus. After that we will discuss some part as per your demand. जे तुम्हाला डिफिकल्ट वाटतो त्याचा आपण रिव्हिजन घेऊया. ओके, सो हियर वी हॅव कन्क्लुडेड आवर युनिट नंबर 5. सो प्रॅक्टिस करा या प्रॉब्लेमची. डाऊट असेल यू कॅन कॉल मी. ओके, थँक्यू.